Hello there, and welcome to your geometry lesson for today. In 4.6, we are talking about similarity and transformations. Similarity and transformations. All right, so what does it mean if something is similar? Well, first and foremost, this little symbol right here means similar. So when we have a symbol like this, that means congruent. And when we have just the single, that means similar to. So like triangle ABC is similar to triangle TOK. So what does it mean if they're similar? So for figures to be similar, first and foremost, they have to be the same shape, but they are not necessarily the same size. So for it to be not the same size, that means it's going to have to go through some kind of dilation that we talked about in yesterday's lesson. But the sides must be in proportion. So the two small sides have to be in the same ratio as the two middle sides and the same two large sides if we were comparing triangles. Okay, so sides must be in proportion. So not necessarily the same size, but they need to be in proportion. So a similarity transformation is a non-rigid motion. So non-rigid motion means we are talking about a dilation. Okay, so it has to go through a dilation, which is a composition, which means two or more different ones, and one of them is going to be a dilation. So two geometric figures are similar if and only if there is a similarity transformation that maps one of the figures onto the other. All right, so an example here, describing the composition of transformation that maps PQRS to WXYZ. So kind of means that this is your pre-image and it moves to this as your image. So this would be the one with the primes. This is where we are ending up. Okay, starting here, then it goes through some kind of composition of transformations, and then you end up at WXYZ. So one thing that I notice here, and we have to compare, I'm just going to do the R because R is right on the y-axis. So R has to end up where Y is. So what happens in order for that to do that? Well, if R is going to stay on R, that means we are going to reflect this across the y-axis. So we're going to reflect across the y-axis. And then you can see that PQRS gets smaller to WXYZ. So if it's getting smaller, we're getting a reduction. So this is 1, 2, 3 units to this 1 unit. So the reduction or scale factor is going to be 1/3. So the composition of transformations here is going to be a reflection across the y-axis and then a dilation of 1/3. All right, some sometimes, always, nevers here. So is this statement sometimes true, always true, or never true? So two equilateral triangles. Are they sometimes true, always, or never? Two equilateral triangles will always be similar. So always be similar. They're the same shape, and their sides are always going to be in the same ratio. Okay, what about two right triangles? Are they always going to be similar? They both have right angles, but do those other ones have to be? So not only do the sides have to be in proportion, but the corresponding angles have to be congruent. So two right triangles are similar sometimes if their sides are proportion and if their angles are congruent. So sometimes they will be similar. Two squares. When are two squares similar? Well, their corresponding angles are always congruent and their sides will always be in the same ratio. So this one is an always, just like the equilateral triangles. And what about a parallelogram and a trapezoid? Will you ever have the sides in the same ratio, all of the sides in the same ratio, and the corresponding angles congruent? And the answer is never. Never, never, never. Okay, on a question like this, if they're going to describe, we just wanted to describe the transformation. On your homework, they're going to be talking about where does P go to X. And so if we start off with P at being at 1, 2, 3, 4, 5, what is that at? -6, comma, 3. And after going through the composition, where does it end up at X? So we're going to reflect it across. So we'd go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But now we have to reduce its size. So this becomes a +6, +3. And now we have to do the multiplying by 1/3. So 1/3 times 6 is going to be 2. And then 1/3 of 3 is going to be 1. So are we at the ordered pair? Whoops, P to, sorry, that P goes to W, not X. So this, I need to erase this. This does not become X. This should be W. P to W. So P, first letter, goes to W. So we'd be at 2, 1. And if you look over here at W, it's over at 2, 1. So on the test, a lot of times, or written things, you're going to have to tell where does that W end up and what ordered pair that is. So this one just asked for you to explain it. Reflection across the y-axis with a 1/3 dilation. And then sometimes they want to know those ordered pairs. So where does P go to W? And so that would end up at 2, 1. Alrighty, that's about it for this lesson for today. So good luck on your homework in lesson 4-6. Have a great day.